I'm back with the third video on exercise 5.2 of chapter AP. If you are new to my channel, then please go through the previous videos based on this topic so that you have a better understanding of the concepts which we are going to do today. Exercise 5.2 is based on the formula an is equal to a plus n minus 1d. In the first two videos of this exercise, I have covered questions based on this formula. In continuation with the previous video, I am going to cover up some more questions based on finding a particular term of an AP. So let's get started. In question number 1, we are given third and ninth term of the AP and we have to find which term would be 0. Let us take the first term as A and the common difference as D. So the third term is A3, which is given equal to 4. As per the formula an is equal to a plus n minus 1d, we get the equation a plus 2d is equal to 4. Similarly, a9 is given equal to minus 8, which implies that a plus 8d is equal to minus 8. As we have discussed in the previous videos, we are going to solve these equations by elimination method of linear equations. So we write one equation under the other, and as a terms are same, we will change the sign of the second equation, and on subtracting them we get 6d is equal to minus 12 or d is equal to minus 2. Now we'll put the value of a in the first equation and solve it. So we get a plus 2 into minus 2 is equal to 4, or a is equal to 4 plus 4, that is 8. Let us consider that the nth term of this AP is 0. So an equal to 0 implies that a plus n minus 1d is equal to 0. Putting the values of a and d which we have obtained above, we get 8 plus n minus 1 into minus 2 is equal to 0. Opening the brackets, we get 8 minus 2n plus 2 is equal to 0, or minus 2 is equal to minus 10, or n is equal to minus 10 over minus 2, that is equal to 5. This means fifth term of this AP will be 0. In the next question, we are given a relationship between 4th and 18th term of the AP. Let a and d be the first term and the common difference of this AP. 4 times 4th term is equal to 18 times 18th term. This implies 4a4 is equal to 18a18. Replacing the values of a4 and a18, we get 4 into a plus 3d is equal to 18 into a plus 17d. Now there is a method of simplifying this equation. You can see that 4 and 18 are multiplied with the left hand side and right hand side respectively, and they have a common factor 2. As we can divide both sides of an equation by the same number, so on dividing both sides by 2, the equation becomes 2 into a plus 3d is equal to 9 into a plus 17d. This makes the equation simpler to solve. Now open the brackets by multiplying the outer numbers with each term. So we get 2a plus 6d is equal to 9a plus 153d. Bringing terms from one side to other and simplifying, we get minus 7a is equal to 147d, or a is equal to 147d upon minus 7 is equal to minus 21d. Let's name this as equation number 1 because we are going to use it further. Now we have to find a22. As per the formula, a22 is equal to a plus 21d. Replacing the value of a from equation 1, we get minus 21d plus 21d, which is equal to 0. So 22nd term of this AP is 0. Are these questions clear? Children, if you have any problem, any doubt, you can comment in the comment box and I will try to answer them as soon as possible. In third question, we have to find which term of this AP will be 132 more than its 54th term. From the given values, we get a is equal to 3 and d is equal to 12. Let us suppose that an is the required term. So an will be equal to a54 plus 132. Using the formula an is equal to a plus n minus 1d, we get this. As a is added on both sides, we can cancel it and thus simplify the equation. And putting the value of d, we get n minus 1 into 12 is equal to 153 into 12 plus 132. I am discussing a trick to simplify this equation. 132 has a factor 12. If you observe carefully, each term of this equation has a factor 12. So we can divide this equation throughout by 12 and thus it will simplify to n minus 1 is equal to 53 plus 11. We have divided every term of this equation by 12. I hope this trick is clear. So now on solving this, we get n is equal to 64 plus 1 is equal to 65. If you are not able to understand this trick, you can also solve this equation directly like the second method shown here. In that case, n minus 1 into 12 is equal to 636 plus 132, or n minus 1 is equal to 768 upon 12 is equal to 64. Therefore, n is equal to 65. So I have discussed two ways of solving this equation. Whichever you find easier, you can apply that. Next question is similar, so please try it. If you have finished, then just check the answer. Again, here I have applied the same trick. As this equation has all the terms divisible by 10, I have divided throughout by 10, and then I got n minus 1 is equal to 30 plus 13. But no problem, if you don't understand, you can apply the second method for solving the equation in that case. The next question is also similar, so please try it. Here A is 3 and D is 5, and an is equal to a20 plus 55 gives us the equation a plus n minus 1d is equal to a plus 19d plus 55, which reduces to n minus 1 equal to 19 plus 11 on dividing each term by 5. And so we get n is equal to 31. The alternate method is also shown here if you want to apply that. In the next question, we are given that two APs have same common difference, and the difference between their 100th terms is 100. We have to find the difference between their 1000th terms. As we have two APs here, we can differentiate them by taking different variables. So let us take A, A2, A3, A4, etc. as the terms of the first AP, and similarly B, B2, B3, B4 for the second AP. As the common difference is same, we can take it as D. So A and B are the first terms of these APs, and A100 minus B100 is given equal to 100. Applying the formula, A plus 99D minus B plus 99D is equal to 100. 99D will cancel, and so we get the equation A minus B is equal to 100. Now we are asked to find A1000 minus B1000. So it will be equal to A plus 9999D minus B plus 9999D. Opening the brackets, these two terms will cancel, and we are left with A minus D, whose value we have already found in equation number 1. So replacing it, we get the value is equal to 100. Now another type of question where we have to find the 8th term from the end of the AP. There are two methods of solving this type of question. In the first method, we reverse the order of the AP, and so the AP becomes 184, dash 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 13, 10, 7. Now the required term will be the 8th term of this new AP. That means we have to find A8 for the new AP. So calculating A and D and putting the value in the formula, we get A8 is equal to A plus 7D, or 184 plus 7 into minus 3, which on solving gives us 163. So this was the first method. The second method is actually a new formula. So if you are interested, you can apply the second method. The formula for finding any term from the end of an AP is L minus n minus 1 into D, where L stands for the last term of the AP. If you look at the given AP, the last term is 184, and the common difference will be 10 minus 7, that is equal to 3. So putting the values in this equation, we get 184 minus 7 into 3, which on solving will again give us the same number, 163. So children, whichever method you like better, you can apply that. So can you try another question of this type? Try, and then you can check your answer. If we use the first method, then on reversing the order of the AP, A is equal to 253 and D is equal to minus 5. So 20th term will be A plus 19D, that is 253 plus 19 into minus 5, which on solving gives us 158. For the second method, L is the last term of the given AP, so it is 253, and the common difference is 8 minus 3 equal to 5. So putting the value in L minus n minus 1 into D, we again get the same answer. I hope all of you could solve the question correctly. Now question number 9. For what value of n are the nth terms of the two APs equal? We are given two different APs here. To distinguish the two APs, we will consider an and bn as the nth terms of these two APs. For the first AP, first term a is equal to 63. We will denote the common difference by d. So d is equal to 65 minus 63, that is equal to 2. Therefore, an will be equal to a plus n minus 1d. On replacing the values and simplifying it by opening the brackets, we get 63 plus 2n minus 2 or 61 plus 2n. Similarly, for second AP, we can take first term as b and denote the common difference by d1. So d1 is equal to 10 minus 3 equal to 7, and we can find the nth term bn, which comes out to be 3 plus n minus 1 into 7 or 7n minus 4. So now we have got the nth terms of both the APs, and it is given that they are equal. Putting them equal, 61 plus 2n is equal to 7n minus 4. Simplifying this equation, we get 65 is equal to 5n or n is equal to 65 over 5, that is equal to 13. Thus, the 13th terms of these two APs are equal. So children, with this we come to the end of our lecture. I will cover up the remaining questions of this exercise in another video. So keep practicing, enjoy yourself and take care.